Hello, in this video, we're going to talk about how to conduct an ANOVA, or analysis of variance, using JASP. So first of all, before conducting your ANOVA, you're going to want to make sure that you have a categorical independent variable and a continuous dependent variable. In this data set, the independent variable is preferred ice cream flavor and the dependent variable is life satisfaction. So what an ANOVA essentially does is it looks at the effect of the independent variable on the dependent variable. So what we're checking is whether mean satisfaction for pistachio lovers is different from mean satisfaction for lemon lovers or vanilla lovers. Now the way we do this is we go ahead and click on ANOVA and click on ANOVA under classical. And you're going to want to move your dependent variable up here and your independent variable under fixed factors. Now, what this is first going to give you is what's known as the omnibus. So that essentially tells you overall, is there a difference between the different levels or groups of the independent variable? So is there a difference in life satisfaction between preferred ice cream flavors, or is there just no difference at all? Now, the way you tell that is by the p-value in classical statistics. So if the p-value is less than 0.05, the result is considered significant. That means there is a difference between groups. If the p-value is greater than 0.05, the result was not significant, no difference between groups. Now, when you're reporting these results, you're going to want to not only include the p-value, but also this F statistic right here and the degrees of freedom, both the 2 and the 26. Now, the next thing you're going to want to do is do post-hoc tests, and that's going to let you know what specific differences between groups were there. So was the difference between pistachio and lemon, lemon and vanilla, between all three different possibilities? So if you look here, it's going to give you each individual comparison. These are known as pairwise comparisons. So essentially all it's doing is conducting a t-test between each possible grouping. So lemon versus pistachio, lemon versus vanilla, and pistachio versus vanilla. So the way you can tell there's a difference, similar to before, you're going to be looking at this p-value. If the p-value is less than 0.05, that means there was a difference. If it's greater, that means there was not a difference. So here you can say the p-value is less than 0.001 between lemon and pistachio. So that means there actually was a difference in life satisfaction between lemon lovers and pistachio lovers. There was a difference in mean life satisfaction between lemon lovers and vanilla lovers, but there wasn't a difference between pistachio and vanilla. Now, finally, you can tell what direction this difference was in by the sign here on the mean difference. So if this value is negative, that means that lemon was lower than pistachio. So mean life satisfaction for lemon lovers was lower than mean life satisfaction for pistachio lovers. Similarly, mean life satisfaction for lemon lovers was lower than mean life satisfaction for vanilla lovers. And again, you can tell that because of the negative sign. If it were a positive sign, it would mean that mean life satisfaction for lemon would be greater than pistachio. So for this type of test, you're going to want to record the p-value. Often you'll want to note the t-value and the mean difference as well. This mean difference is just letting you know how big the difference was. So here you can tell the difference was about 2 units. The difference between pistachio and vanilla was very small, and that's why the p-value ended up not being significant. I hope that helps, and thank you for watching.